Hello and welcome to today's IBM Rational AppScan Source Edition product demonstration. My name is Chris Robinson and I'm a Sales Development Manager here at IBM Rational. With me today is Tony Vera, who will be running the product for you. Tony is a customer-facing IBM Rational engineer who focuses his efforts on the AppScan family of application security solutions. Today's presentation will last approximately 45 minutes, and we will answer questions from the audience at the end of the demo. Attendees should stay on mute for the duration of the presentation and use the chat Q&A function within your browser window to send questions our way. As you might imagine, IBM offers products and services that address virtually every aspect of IT security. AppScan Source Edition is part of the Rational family of products that focus on threat detection within the application layer, which account for over 80% of all IT-related security breaches. So what we're going to show you today is the static analysis tool. It's commonly known as a white box solution, and it scans the source code of critical applications for security vulnerabilities. The point is to find those vulnerabilities early in the software development lifecycle before apps go into production, when the flaws are still easy and inexpensive to fix. AppScan Source Edition was designed to be used by people with differing roles and different levels of technical ability within your organization. There are plugins that cater to security staff, developers, and executives. At the heart of the product suite is the Source Edition Core, which is the server component, and that contains the analysis engine, a database, and our award-winning knowledge base. Today's demo will focus on the security plugin, which is the power user component of the product. This is where policies are set, scans are run, our results are triaged, and reports are built. We're going to show you a couple different reporting features that pertain to auditors and also to developers. And part of that developer reporting feature is an IDE plugin that enables developers to open the reports within their IDE, and those reports tell them what vulnerabilities were found, where in the application, what line of code they were found in, and then it hooks them up to our knowledge base where they can look up ways to fix the problems and just general ways to write more secure code in the future. So with that, I'm going to hand things off to Tony Vera, and he's going to run the product for you. Bear with us just 1 second while we pass the baton.
Okay, thanks, Chris. Hopefully everyone can hear me and see my screen. I currently have a website up called altaromutual.com. This is a website that IBM has created with the specific intent to litter it with a wide variety of vulnerabilities that people can use to experiment with websites to understand the implications of those vulnerabilities. This is a public website. You can feel free to visit this on your own. So what I'm going to do is I'm going to attempt to sign in to this application, and I'm going to do so not having any sort of information about what the potential username or password might be. So I'm doing this from the perspective of a hacker. And what we're going to do is we're going to try to log in using a SQL injection hack, and then from there we'll move into the tool, the source scanning tool, and we'll actually locate the source of that particular flaw. So as a hacker, a real typical thing I might do initially to see if I can break the SQL engine or to see if the application filters out any SQL commands is I'm going to use a tick mark to tell the application that a SQL command is coming, use a logical expression 1 = 1, and terminate with a comment to terminate the SQL command. I'll put garbage in for the password and attempt to log in. As you can see on the screen, I've been greeted as the admin user. So I was successful in sending a SQL command to the SQL engine which tells me that the application did not filter the fields on this login page. So we're going to experiment with this particular vulnerability using AppScan Source. So I brought up AppScan Source, and we can see that towards the top, this is a Eclipse perspectives. We see three perspectives: the configuration perspective, triage, and analysis. So what I'm going to do today is kind of walk through day in the life or a typical scenario for doing source code scanning. And in that scenario, I'm going to wear two different hats. I will wear the hat of a security analyst who might actually perform the scan, configure rules, look at the results, triage those results, and assign the detected vulnerabilities to developers. I'll then switch hats to the developer role and try to understand why this is a vulnerability in the code and fix the code, turn it back over to the security analyst who will verify the fix and mark up the application so that that particular vulnerability, after it's been confirmed as fixed, never gets flagged as a vulnerability going forward. So the first thing I'll typically do for a new project is create the project and pull in the source code for the project. Now, if you don't happen to have source code, but you have the intermediate representation that was compiled with debug turned on, then in that case, you don't even need the source code. You can just pull in the binaries. So in this case, I pulled in the Java code for my Altero Mutual website, as you can see. And for the sake of time, I've already clicked on the scan button, told it to scan the entire project, and in the lower right window, in the console window, you can see the results of the scan. It looks very much like a compiler because that's what this tool is doing, is analyzing the semantic and syntactic structure of the code in order to build a model of the application. And in that model, it's going to look at various patterns in the code. It's going to look for inputs into our system. It's going to look at where the data goes in our system in terms of communication. And then it's going to look where the data ends up going outside of our application, such as perhaps a file write, or perhaps a write to the client's web page, or perhaps a database, which would be the situation that I demonstrated for the hack, where we tried to use send a SQL command as the username that got ultimately sent to the SQL engine and executed by the SQL engine. So after scanning the application, the tool will automatically take me to the second perspective called the triage perspective. This is where many times it would be a security analyst that's spending a lot of time in this particular perspective. And in a typical scenario, they would look towards the upper right here. We'll see our vulnerability matrix. The vulnerability matrix has the two axes. The horizontal axis is the classification axis. So we see that there's three classifications of findings. We have vulnerabilities. These are confirmed vulnerabilities. We know with high confidence that those particular findings are problems that will need to be fixed. We also have type 1 vulnerabilities. These are vulnerabilities where there's a high type 1 findings. These have a high probability of being vulnerabilities, but they will take input from people with remediating those findings. And then finally we have type 3 findings. Those are ones where we think there's an issue there that needs to be analyzed, and some of those may end up being classified as vulnerabilities ultimately, and some of those will simply be flagged as noise or as false positives or things that we don't need to be concerned about. And then on the vertical axis we have the criticality. So obviously, high criticality finding would be something that we want to get fixed right away because it can lead to a lot of damage in our application or into the data that we have in our system. And then, of course, moving down to medium and low. The nice thing about this vulnerability matrix is we can click on the various aspects of the matrix and in order to filter the data for just that slice or view of the findings. So if I click on a vulnerability, it shows me all of the vulnerabilities that were found. I could click on just the high, and it shows me all of the classifications, but only the ones that are critical. And you can even just click on a particular intersection or cell within the matrix, and it'll show me all the data for that. And as you can see, as I was clicking around throughout this, this matrix, that all of the data throughout the rest of the windows are automatically refreshed to show just that intersection or just that particular slice of data. So I'm going to go ahead and reset the findings to show all of them. We'll move on to the upper left window where we're looking at the summary by a number of different views. Right now we're looking at by vulnerability type. You could also change it if you want to see maybe by the particular method or API that the findings were associated with. So we can see a view of that. And you could even click on just particular bar or bars within here in order to get just that particular slice. So the purpose of this is really to give the user a very nice way to get to the heart of what is of particular interest to them at that point in time. So moving down then to the details of the findings in the lower left, we can see that it lists all of the findings based on the selection we made in the bar chart and in the vulnerability matrix. So from here we can start drilling down and getting to various details of the findings. So as I click down on actual instances of the findings, then you'll see that the window on the right where the details are shown gets refreshed to show just that cross-section. And in that window, in the details window, we can see if there's a trace diagram associated with it, which we'll be talking about in a moment. We can see the API that was affected, the source file, and there's also some sync information, which I'll talk about also in a little while. And then right down to the specific method and file that that particular finding was associated with. So in this findings view, we can look at those findings in a number of different ways as well. So if I come over here and look at the hierarchy in a different way, I might want to look at the data instead of by vulnerability type, maybe by classification. So this breaks the data down by, is it a vulnerability or type 1 or type 2? We might want to look at it from a CWE or a common weakness evaluation perspective, in which case all the data gets refreshed based on CWE classifications. So the other thing I could do is go to my report view, and this is a handy view if you're under specific compliance requirements. So for example, if you're obligated to comply with DSA or like commonly DOD, or maybe you want kind of an OWASP top 10 view of the findings. Perhaps you're handling credit card data and you want to look at the PCI view. So we have a number of different ways to look at this data. So let's go back to our findings view. And based on the hack that I demonstrated for you, I mentioned that that was a SQL injection hack. So let's just kind of drill down on our SQL injections, and we'll look at some of the details for that. So in there we can see that we have some 19 high criticality, which are vulnerabilities. There's some type 1s and some type 2s. I'm going to look at a type 1, and as you can see then all of the data gets updated for all of the instances of those type 1s. So we have 17 instances of type 1 findings. I'm going to click on one of those, and suppose that I'm not an expert yet on security, application security. There's a remediation assistant that I can expand, and it takes on the context of the particular vulnerability that I've selected. So in this case, we're looking at SQL injection. So this basically is a link to the CWE repository, which is a really valuable resource for really understanding what is a SQL injection, how do we detect it, what are the possible what's the possible damage that could result from such an attack, all the way down to even code examples for how do I recognize a SQL injection in the code and how do I correct it. So this is a very powerful tool to help educate people or somebody who maybe is looking at a vulnerability that they haven't seen in a while. So it's valuable from that perspective. So let's go back down to the detail of one instance of the SQL injection. And I'm going to double click on it, and it's going to automatically take me to the third perspective within the tool, which is the analysis perspective. So the analysis perspective would probably be heavily used by a security analyst and possibly even by a developer, again, depending on how the responsibilities in the organization have been allocated. So in this view, you can see in the top two windows the same information that we saw in the triage perspective. But then as we move down, we see some much more interesting things and some more detail about that specific finding. Okay, so the first thing that your eye is probably attracted to is this trace diagram. So this is going to give us a lot of intuitive information about this particular vulnerability. I'm going to expand that window so you can see a little bit more of the diagram itself. And here we can see the trace diagram. So this is basically each API involved with this vulnerability, one particular instance, and it's going to show us where the data and the calls go. So in this case, we have the servlet login servlet doing a do post is going to call the servlet request in order to get a parameter. And based on the color coding, which hopefully you can see on your monitor, you can tell what's happening to the data along its path throughout the system. So the pink or red servlet request get parameter tells us that this is a source of tainted data. And by tainted data, we're saying that the data that comes out of this particular API has the potential to be tainted, meaning we can't trust that the content of that data is safe. So we're returning from the get parameter tainted data back up to the login servlet, and it's then being passed as a parameter to one of our particular parts of our application called isValidateUser within the dbutil function. So we can see that that particular API, it's gray, which means we cannot confirm that this thing validates or does not validate the data. So based on that, the tainted data, as it's being passed out of the isValidateUser call, is going to potentially also be tainted. And then finally, we see a bunch of APIs at the bottom. Most of these are built in fact, all of these are built into the Java Lang libraries. And the blue ones indicate that we've already pre-marked these up. And this is done by IBM ahead of time, so you don't have to worry about doing it. These are marked up as not validation routines, meaning we know that they absolutely do not do any sanitization of the data. Therefore, every time a call is made down with tainted data, any return value is also going to be tainted. And finally, if we look to the far right, we see the SQL Execute Query API. This, if you see the little tooltip that pops up, it says that this is a sink. And this is the term that we use to describe when data goes out of our application to somewhere, and that sink could be potentially damaging. In other words, if we write data to a database, which is the case we're seeing here, that a database write would be a sink. And since the data that's being passed into the Execute Query API is tainted data or potentially tainted, and this is the key point that we identify we have a vulnerability. Well, we have a potential vulnerability. And the reason it's just a potential vulnerability, which makes this a type 1 finding, is because we don't know yet what the isValidateUser routine is doing. So this is of particular interest to a security analyst because we're saying, well, this is our own code, and we don't know what it's doing yet. Is it sanitizing the data or not? So this is an area we need to investigate further. So to do that, as an analyst, I would probably want to find out, well, where else do we have this pattern showing up in the application? In other words, where else are there calls to isValidateUser? So the tool makes it very easy to identify throughout the application where this occurs. I can simply right mouse on the API and select the item that says search for traces through this routine. So we have already built the model of the application during the scanning, and now I go ahead and execute that search, and it finds two instances throughout our application where we have the same trace through the isValidateUser. So I've clicked on both of those so you can kind of see what the different data flows look like. Now, if we want to drill down just a little bit further, we could click on these APIs, and you'll see that the code down below changes to reflect those particular mouse clicks on the APIs. So we get right down to the specific line of code that's of interest. So as an analyst, if I look at the code and maybe I understand it, what it's doing, maybe I don't. But at this point, I'm probably going to pass it over to a developer to analyze further and make the necessary fixes. So in order to do that, in order to make that assignment, I'm going to select both of these findings at the top here, and I'm going to create what's called a bundle. So I'll add to bundle and tell it to create a new bundle. A bundle is nothing more than a package or a container for one or more vulnerabilities. And I can classify those in any manner that I see fit. So I'm going to call this validate user bundle. And I'll probably put some useful notes in here so that the developer understands what my rationale was for identifying these as potential problems. Click OK, and then over on the right here we can see my validate user bundle. If I click on that, then I can see the details of the bundle. And again, there's my two findings. So at this point, I need a way to communicate this bundle to one or more developers. So there's a number of ways I could do that. I could submit it to a defect tracking tool or a change tracking tool. So in this case, we have 3 or 4 out-of-the-box integrations to various bug tracking systems. We have Rational Clear Request, Quality Center, Rational Team Concert, as well as Microsoft Team Foundation Server. Those are just the ones that are out of the box. In this case, I'm just going to go ahead and do a really simple one, a generic one. Let's suppose I don't have a defect tracking tool in place. I can just simply send this to an email, an individual or a group. I'm going to send this to a developer and click OK. And at that point, I'm going to take off my analyst hat and I'm going to put on my developer hat. So as a developer, I'm going to go into my email and I'm going to refresh the email, and you'll see that I just received a new email, and I open that up and I can see the details of the bundle that was just sent to me by the analyst. So you can see that there's the two findings and a variety of information that helps me get some context for what these findings are about, including what was the vulnerability type, what's its severity, what file name did it find the vulnerability in, and it actually takes me down to the specific line of code in that file that's of interest. So at this point, I'm going to go ahead and save the attachment, which contains all of this, the information for the bundle. And I'm just going to go ahead and, for convenience, put this bundle on my desktop and save it. And now I'm going to go into my IDE. And for this particular demo, I'll just arbitrarily choose the Eclipse integration or IDE. We also have integrations to other IDEs, including .NET. So if I open up Eclipse as a developer, you can see I'm doing some other work here, some other development activities. So knowing that I have a new assignment to work on the validate user or login bundle, I'm going to go ahead and open that up. And there it is on my desktop. And then brings that bundle into the context of my development platform. So as we see here towards the bottom, there are the two findings. And I can click on those, and immediately I see the other important information about that particular finding. Again, just like in the analyst application that I just showed you, there's a remediation assistance that tells me a lot of information, including code examples, remediations, and so on. And then I have, of course, my trace diagram. So as a developer, I'm going to be clicking around in this trace diagram, and as I do so, it's going to take me to the specific code associated with that API. So in this case, if I go to the, this is, again, our application code. This is the DB-util, the isValidateUser API. And sure enough, we can see that we're passing in a username and password string. And then as we see that tainted data traverses to the actual execute statement, again, this is inside of the DB-util routine, then we can see that we're doing the SQL execute, and we're not doing any sanitization of the data. So I'm kind of looking at a few lines above and below the line of interest to figure out what's going on. And again, so my conclusion as a developer is, well, we're getting this username and password string. We're not sanitizing it or passing it to the SQL engine, and that's dangerous because they could do the exact same hack that I demonstrated initially. So what I would more than likely do is add some code or maybe even another routine within this isValidateUser API in order to sanitize the data and strip out any potentially damaging characters or strings that could be executed harmfully by the SQL engine. Once I make my fix as a developer, I will communicate that fix back to the analyst or analyst team via whatever means is appropriate. It might be my change tracking system or defect tracking system. It might be by email, whatever makes sense for your organization. So taking off the developer hat, going back to putting on my analyst hat, and I'll go back in here. I've been notified that the fix for this particular bundle or this vulnerability has been made. So what I'll probably do is go in, explore it by clicking on the area that's suspect, looking at the code, ensure that the proper changes were made. If I'm not sure, I can go back into my remediation view and get some details about, what are the examples of good code versus bad code, what needs to be done to fix this particular problem. So please note that down here in the code window, you'll see some little color-coded symbols along the left side. And if you just mouse over those, you can see that there are various annotations, and it tells you basically why it's flagged that particular line of code as an issue. So in this case, let's look at one of interest. Okay, validation required. I'm looking basically for a SQL injection issue, and here's one. You see the tooltip pops up injection.sql. We have 2 instances, which we know that we have 2 instances. So based on that color coding, I'm going to come in here and I'm going to say, well, I've analyzed the code or the change that the development team made, and I've validated that, yes, we have fixed this problem. This should no longer be flagged as a vulnerability. So this is a very powerful capability within the tool. I can write custom rules within AppScan Source without doing any coding or scripting or custom configuration or anything like that. I can simply use the GUI, right mouse on the API that I've fixed, and I can mark it based on whatever the conclusion is. In this case, I've added code that validates the tainted data that may be coming in. So I'm going to mark this as a validation or encoding routine. And you can control the scope of that markup. And at that point, I've created a custom rule. So the custom rule, as you can see, I flipped over to the custom rules tab, and you can see it shows up here. And at that point, I have a custom rule in place. And as Chris pointed out in the introduction, we have this thing called the AppScan core. That is the central knowledge base. So whenever I create a custom rule, that is going to be updated in the central core so that everyone inherits that custom rule. I'm going to click the Scan Again button so that we can see if indeed subsequent scans do not flag this particular area as a vulnerability. Now, the scan does take some time. So normally we would do some Q&A at this point. So Chris, do you have anything that you want to cover? And I think Chris's audio is probably off, so I'm going to move.
Yeah.
Oh, Chris, are you there?
Chris, are you there? Yes.
Okay.
We have received a few questions. First one is, what other source code languages does the product support besides .NET and Java?
Okay. We support, and Chris, you might want to turn your mic off while I answer so there's not too much echo. We support, in essence, the vast majority of any contemporary language. So this would include things like, C++, all the .NET languages, C#, VB.NET, the Visual Basic or Visual Studio 6.0 legacy stuff, Perl, Java, JavaScript. The list goes on, and I don't memorize the list, but it pretty much covers the vast majority. And so any of you on the call that are using a particular language extensively that you would like us to substantiate that indeed we support it, just let us know. Also on our website, it lists all the major languages. But again, we support almost all of the contemporary languages.
Okay, thanks, Tony. We have time for one or two more questions. And we get this question a lot on most of the demos that we run. The question comes from an attendee who is already using the AppScan standard dynamic testing solution. And the attendee asks, what's the difference between these two products, and does he need both?
Yeah, that's a great question. And like you said, Chris, we get that very often. And, you know, it's a matter of degrees. It's a question of how much risk are you willing to bear on your web application. Most of our customers say we want to minimize that to as much of an extent as we can. Basically, because these are radically different approaches, dynamic scanning, where we're actually doing live injection of attacks to a functioning website, that uncovers certain types of vulnerabilities in a dynamic way, and we get very high confidence that because it's live, it's functioning at the time of the attack, we know that those are real problems. On the other hand, source code scanning, we can gain high confidence that we have a great degree of source code coverage because we're actually analyzing the lines of code themselves. Whereas with dynamic scanning, if you complete a website scan and then ask the question, how many lines to answer? With AppScan Source, where we're actually looking at the lines of source code, we know precisely what source code we've actually exercised or analyzed. We get a higher AppScan Source, we don't even have to have a deployed application even to a test server. This can be done, and we can do the scans early in the life cycle when the fixes are much less expensive to implement.
Okay, thanks, Tony. We're about to be at the end of the time allotted for this. We generally try and keep this under 45 minutes. If we haven't answered a question of yours, we'll do so via email after the presentation is over. Tony, do you want to just finish things off?
Okay, very good. So as you can see in the lower right window here, the scan has completed. And the other thing I'd like to note is that in the code window, remember all the color codings that we saw along each of the lines of code where we had some particular areas that were of interest. Those have been removed. So this particular section of code is no longer of concern. You'll notice that the window towards the top here for the SQL injection findings, those particular findings have been removed. So we used to have 17 type 1, we now have 15. And of course the trace window for one of those findings is blank now because of course that is no longer a finding. The other thing that we can do is we can go back to our bundle and you'll see that those two findings that we had detected before, they're now color-coded green. So that tells us, hey, these are no longer of concern. The scan has confirmed that they are no longer of concern because the data has been validated by one of the routines, and that was the one that we marked up. So, so that's kind of a real quick whirlwind tour of some of the core capabilities using the typical scenario. I'd like to just spend a minute or two also looking at the some of the reporting. So let's generate a simple report here, and I can use the report tool and get a report that's of interest to me. You know, if I'm concerned about credit card data, I might want to do PCI. It seems like a lot of companies, maybe the majority, tend to be focused more on OWASP top 10. So let's just go ahead and do that. And I'm going to generate this report. I'm going to just put it on the desktop for convenience. And let's go ahead and run that. And again, you saw that I had a number of different options in terms of it appears that maybe my screen is no longer sharing. So I'm going to flip back over to the sharing window. I apologize for you losing visibility here, but that's okay. I was just generating the report. And now the report is completed. And you can see the report on the screen. So again, I decided to use HTML. You could do PDF or Excel or whatever makes sense to you. So we're just looking at the HTML report that was generated. And this is all extensively hyperlinked, so you can navigate through. And I'll just pick one at random here. And it gives you deeper and deeper level of detail, all the way down to the particular API, the file that was involved, and then even the line of code that was of interest for this particular vulnerability. So that's an example of a report. And there's also a findings report, so we can do it, again, by different classifications or different slices or views of the data. So I won't do any of these now for the sake of time, but again, it just gives you an idea that there's quite a wide range of reports, and you can also create custom reports. So perhaps the last thing that's just a new capability in 8.0 of AppScan Source is an auditing tool. So a lot of our customers have been telling us, you know, we do get audited, and we do need some sort of traceability, some tracking for what's going on in this tool. We need some history and traceability. So we put in the audit capability to give us a log of what's going on in terms of authentication. So who's logging into the tool when, what's their authentication level, is the action that they performed, was it successful or not. There's user management tracking, so if somebody adds or removes users or changes their privileges, that gets tracked. Assessments are basically the results of the scan, and as they get published up into the core, that activity would get tracked as well. And then, of course, anybody creating custom rules or scan rules, those get tracked as an auditing function as well. So that's it for the quick tour of AppScan Source. We would like to invite you to contact us if you would like a deeper dive and an on-site visit or whatever makes sense for your organization. So feel free to reach out to us. Chris is putting us some contact information. Feel free to reach out and let us know if we can help you further. Chris, back to you.
Well, that brings us to the end of our time. So thank you very much for attending, everyone. We hope you found this informative. As Tony mentioned, if you have additional questions or would like to take a closer look at this product, please let us know. You can contact me, Chris Robinson. There's my email address and phone number. You can also contact my colleague, Shani Lontine, at the email or phone number listed. So thanks a lot for attending, and have a great day. Thank you, Tony.